Independent. Do you know what that means? All right, so I'm right with little boozy on this one. Do you know what independent means? And likewise, do you know what dependent means? So let's think about it. Independent and dependent events. Okay. Now, if you look up here at the top, for both of these, we're going to use the probability of A and then B, meaning one happens and then the other one happens. Then think of means when. So A happens first, then B happens second. We take the probability of A times the probability of B to get that. Now, the difference is when it's an independent event, A and B will both be the same no matter what happens, okay? If it's a dependent event, dependent means it depends on what happens before it. So then after we do event A, event B's likelihood will change. Now, let's first talk about if we're rolling a die. So if I roll a die and get, say, a 5, okay, does that make my next roll more or less likely or the same likely to get another 5? And hopefully you say it's the same. Okay, I still have a 1 in 6 chance. Just because I rolled a 5 doesn't mean the next one is less likely to be a 5. It's still 1 in 6 chance. Okay, so in this case, when we're rolling a die, it's going to be independent. Okay, they're independent of each other. So the chances of rolling a 5 would be 1 over 6. There's 6 things on our die, our standard die, and one of them is a 5. Okay, now if I roll it again, chances of getting a 2 on my second roll would also be 1 over 6. Now all we have to do to get our final answer, we just multiply. So 1 times 1 across the top gives us 1. 6 times 6 gives us 36. We have a 1 in 36 chance of rolling a 5 on the first roll and then a 2 on the second roll. Now, if we look here, rolling a 3 and then rolling another 3. Okay, there is 1 3, so 1 over 6. The second time, there's still 1 3, so 1 over 6. This is the exact same likelihood as what we did on this first example. Okay, now let me scroll down a little bit. And it says example 3. Let's think about our chances of rolling a 1 and then an even. So chances of rolling a 1 would be 1 over 6. Now, chances of rolling an even, that can be 2, 4, or 6. So that's going to be 3 over 6. Now, if we take 1 over 6 times 3 over 6, we're going to get 3 over 36. We're not quite done, though, because that can be reduced. Okay, so 3 goes into 3 one time, 3 goes into 36 12 times. Now we would be done. Okay, now our second situation. We're pulling marbles out of a jar. It says there's 3 red marbles in this jar, 7 white marbles, 5 blue marbles, and after each is picked, it is replaced, meaning put back in the jar. Now that's the key thing here. After each one is picked out, we put it back in the jar, and they're all mixed up, and we have a random chance of getting each marble, just like before. Now, this will also be independent because it's replaced each time. The fact that I pulled a blue one out the first time does not change my odds the second time. Now, it says, what are my chances of picking a blue and then a red? So first, let's figure out how many marbles there are in the jar. So we've got 3 reds. Oops, let me get my number back. So we got 3 reds, and I don't think I have a white option, so I'll go with the light blue. 7 whites, and now 5 blues. 3 plus 7 plus 5, add that all up, and we have 15 total marbles. Okay, so the chances of getting a blue one, there are 5 blue ones, and there are 15 total. So I pull that marble out, 5 out of 15 chance I'll get a blue. Now it says, after each pick, we replace it and put it back in the jar. We're assuming we don't intentionally set it on the side. Okay, we put it back in, and there's the same random chance that we'll get each of the marbles. So it'll be 5 over 15. Okay, and then we're going to multiply that by, what are my chances of getting red? There were only 3 reds, so it would be 3 over 15. Now, at this point, you have a couple options. You can either reduce now and then multiply across, or we can multiply and reduce later. I don't care what you do. 5 times 3 will give us 15 on top. I'll reduce later. 15 times 15 gives us 225. Now, if we have 15 on top, we know 15 goes into that, because that 225 was 15 times 15. So we can reduce, and we're going to be left with 1 over 15. That are my chances of pulling a blue one and then a red one. Okay, now example 5. This time, there are 3 things we need to have happen. Pick red, put it back. Pick a blue, put it back. Pick a white. Okay, 3 things. Same exact thing, except now we're going to add another one to multiply. Okay, so chances of picking a red, just like up here, it's still 3 over 15. Okay, so I pull a red one out, put it back. Chances of pulling a blue, same as the first problem, 5 over 15. Okay, now chances of pulling a white, it's going to be 7 over 15. So at this point, it's up to you. You can either just multiply across, or one trick might be easier to save you some time is let's simplify early on. Okay, so if we look here, I'll use a different color. So this 3 and the 5, 3 times 5 gives 15, so that can cancel out. And we're left with just a 7 on top, all over 15 times 15, 225. Okay, so if you're not sure, I did that 3 times 5 is 15. Since it's on the top and it's all multiplication, that can cancel out with the bottom. If an easier way to maybe do that is think this 15 is the same as 3 times 5. That 3 cancels with that right here. The 5 cancels right there. Okay, and we're left with 7 over 225. Now, all of these were independent because the second, and in this last case, the third event, were independent of each other. They did not change their probabilities. We're going to scroll now to the next one. And here, we're going to get some dependent situations. The key reason why, it says marbles in a jar. There are 3 red, 7 white, and 5 blue. Same exact jar we had before. However, now, after each is picked, it is not replaced. Okay, now the reason this changes things, let's see, if we, on the front side, whoops, I'm out of control. If we pick this blue, that did not change the number of marbles. The next one still had a 3 over 15. However, now, if I pick one out and I don't replace it, that means there's going to be less marbles, so a higher chance that I'll get a white. So it says, let's go ahead and pick a red. Okay, so my chances of getting a red, there are 3 reds, so it's going to be 3 over 15. However, if I pull that red marble out and I don't replace it, I keep it right here in my hand, that means the next time I pull a marble out, there's only 14 marbles in the jar. There's still 7 of them that are white, so it'll be 7 over 14. Then we go ahead and multiply. So 3 times 7 is going to be 21. Let's see, 15 times 14 is going to give us 210. Now, hopefully you see 21 over 210. 21 times 10 is 210, so that'll be 1 over 10 is what we'll get when we reduce that. Okay, let's scroll down a little bit. And now, same thing, except we're picking a red, then a blue, and then another red. So, chances of us picking a red on the first one, still 3 on a 15. If I pull that red out, now there's only 14 marbles left. Chances of picking a blue, it's going to be 5 over 14. And our chances now of picking another red, now we have to be careful here. There were 3 at the start right here, but we already took one out. So there's only 2 left, okay? There are also were 15 marbles at the start. We've taken 2 of those out, so there's 13 marbles left. Okay, now, the top, I'm sure you guys can handle. 3 times 5 is 15 times 2 gives us 30. Okay, the bottom, I don't expect you to do that in your head. 15 times 14 times 13. Okay, so once again, go ahead, calc 2.0 calculator. Okay, we click on it, and Then we do 15 times 14 times 13. And we'll get 2,730. Okay, so 30 over, oops, let me put that back. 2,730. Now at this point, we can go ahead and reduce that. And 30 does actually go into 2,730. So if we divide that by 30, we get 91, which means our final answer is going to be 1 over 91. Okay, we've got one more problem for us here. This time we're picking 3 whites in a row and then a blue. So once again, 3 reds, 7 whites, and 5 blues to start. So the chances of picking a white 3 times in a row. The first one, 7 over 15. However, now there's one less. So our next one, chances would be 6 over, one less marble in the jar, 14. Next one, there's one less white, one less marble, so it's going to be 5 over 13. Now, at this point, the blue, there are still 5 blue marbles, so we're going to put 5 up there. Over, and we can put a 12. Okay. Now, once again, it's up to you how you choose to do this. Okay. You can multiply the top across, the bottom across, and then reduce. An easier way, some of you might think, is let's do some reduction now. Okay, so 14 breaks apart to 2 times 7. That 7 will cancel out. Okay, 6 can cancel out here with a 2 times 6. So we know that 6 will cancel out. We've got a 5 and a 15 would be 3 times 5. So that 5 and that 5 will cancel out. Okay, now at this point, we are left with just a 5 on top. 3 times 2 right here and here gives us 6. Okay, 6 times that 13 is going to give us 78. And then 78 times 2 will give us 156. Okay, so we have 5 over 156. Double check real quick. Can anything be reduced? And in our case, no. So hopefully you didn't get too confused on what I did there with reducing. If you did, go ahead, just multiply 7 times 6 times 5 times 5. If you do that all the way across the top, you'll get 1,050. Okay, then 15 times 14 times 13 times 12. If we do that across the bottom, we'll get 32,760. And from here, we can simply cancel the zeros, okay, reduce it down, and you'll get down to 5 over 156, just like we did before. Okay, so if you have any questions, please let me know. And in the little words of Little Boozy, INDEPENDENT, do you know what that means? Hopefully the answer is yes.